Hello students, myself Ramesh Masuna, Faculty Computer Science Engineering. On behalf of ACE Engineering Academy and ACE Online, I am welcoming all of you for this session of Railway Recruitment Board Junior Engineers. And the subject is Database Management System. And coming to the database management system, we have certain topics in the syllabus. The topic is Entity Relationship Data Model. This comes under database design. And we have a relational model because a database is going to be represented in the form of tables, and each table is called one relation. And then we have a concept called normalization, means on a database tables that you have created, if it had some problems and that problems has to be analyzed and minimized before the implementation itself and try to minimize them. This process is called normalization process. Here, these three steps, that ER model is called conceptual database design, where a concept is converted into diagrammatical notations. And relational model, where the diagrammatical notations are converted into table representation of the database. And third one, normalization, that table representation is going to be refined for the problems and minimized. This is called normalization. And these three steps comes under database design. And next we have relational algebra. It is an expression language where how the data is going to be retrieved from the database is going to be expressed in the form of an expression using some notations. This is to understand the process how data is going to be retrieved from the database. If you understand the process, we can convert that process in the form of a structured query language. And we also have another topic called PLSQL. And SQL and PLSQL, the difference is, now in PLSQL, the procedural language features are added with SQL. We call it as PLSQL. We call procedural language, structured query language, PLSQL. It means the kind of if statement, while statements, for statements that we can add it to the SQL to make it into PLSQL. And these three topics comes under implementation. So here I have divided the syllabus of RRB JE into two broad categories we call database design and database implementation. Here in this session I am going to talk about relational model. What is relational model and how data is going to be represented in relational model, because the database system that we are using is called RDBMS. We call Relational Database Management System. Here I am going to talk in this session about R. R is nothing but relational data model. Right. And also we will see what are the kind of questions asked on relational model that we are going to discuss. Yeah. Here we see that in relational model, database is going to be represented as collection of relations. Each relation is called one table. Each relation is called one table of records. Okay. Now, see, a relation consists of, it is nothing but a table consists of set of tuples. Here the tuple is used as a synonym to represent a record in the database. What a table contains? Records with set of attributes. Generally table consisting of rows and columns. Each row generally we call one record. Each record is called one tuple. And table contains column. Each column is called one attribute of a tuple or attribute of a record. Now you see, each relation is described using two things. One we call relation schema and another we call relation instance. Now what is a schema and what is instance? Just have a look. A schema is specifying the structure of a relation. Schema means structure. Suppose I do have a table called student. Let us say I do have a table called student. And the student having some attributes, roll number, name, and marks. Roll number, name, marks. And roll number will take the values of type integer, and name will take characters, a sequence of characters comprising of maximum 10 characters. And marks is of type integer. And here, roll number, on roll number, we would like to add some constraint. That constraint I am calling it is a primary key. The primary key means it should not allow any null value and should not allow any duplicates. And this representation is called relation schema. Schema means structure. Now what the schema is specifying? The schema is specifying what is the name of the relation and what are the attributes in the relation, what is the domain of each attribute. So this is called int, char of 10, int is called domain. Domain specifies the range of values. What range of values are allowed in that particular attribute of a table is called domain. In programming language, generally we can call data type. In query language, we call domain type. And any constraint is nothing but any conditions on any particular attribute that we have to specify on that attributes. So means what schema specifies? 4 things. Name of the relation, attributes in a relation, the domain of each attribute, and constraints if any. This is called a relation schema. And the next thing we call relation instance. Now what is an instance? Instance specifies the tuples is nothing but records present in a relation at a particular moment of time. At a particular moment of time, what tuples are present in a relation is called schema. Yeah, have a look. Suppose initially I do have some tuple called 1, Swara, and marks 25, and 2, Shiva, marks 21. So these are called the records in a table. These are called records in a table, or we also call tuples in a relation. Here, at this moment of time, how many tuples are present? 2 tuples are present. This is called instance of a relation. Means instance means at a particular moment of time what tuples are present in a relation is called instance. Here I would like to add 2 more things. See, the schema is specifying the structure, instance is specifying the tuples. Here I would like to use 2 things called degree and cardinality. Look at what is the degree of a relation, what is the cardinality of a relation. So degree of this relation is 3. It is meaning that the number of attributes in a relation. Means what degree of a relation specifies the number of attributes in a relation is called degree. What is the cardinality? Here the cardinality is 2. The cardinality specifies the number of tuples present in a relation instance. In an instance, how many tuples are present? That number of tuples present in a relation instance is called cardinality. These are the 2 things. Here, look at practical question. Practice question. Identify the correct statement. It is MSQ, but in RRBG you don't expect MSQs. Okay, but all are MCQs. Only one option is correct. But okay, you can solve this kind of questions. Identify the correct statements. Look, employee ID, employee name. Employee is a relation. These are the attributes of a relation. Specifies a relation schema. Means what it is talking about, this is talking about a structure. If anything that is talking about a structure is called schema. So this is a correct statement. 12 Jessica is an instance of a relation schema. It is, what is the meaning of instance? A tuple or tuples present in a relation at a particular moment. What is 12 Jessica? Is it a structure? No, it is a tuple. So this is also correct statement. And see, look at 12 Jessica specifies a relation schema. Schema means it should specify a structure but not a tuple, but the 12 Jessica is a tuple, So it is incorrect. And D12 Jessica is neither a relation schema nor an instance. It is not a relation schema, it is a true statement, but nor an instance of a relation. But what is an instance is a tuple, but this is a tuple, so this is an incorrect statement. So what is the correct statements? A and B are the correct statements. So you may expect some basic questions in the RRB JA. Okay. Have a look a concept called integrity constraints. Now what is the meaning of this integrity constraint? Simple. What is the meaning of constraint? Constraint is nothing but condition. Simply say condition. See, it is a condition on what? On a relation schema. It is a specified on a database schema. So if condition is there on the particular attribute of a table, so it is going to restrict the tuples that can be stored as an instance of a database. So means some tuples that you would like to store in the database, and if that tuple satisfying all the integrity constraints, means all the conditions specified over the database schema, then only the tuple is going to be stored. Otherwise, the tuple is going to be restricted. Restricted means it is going to be rejected. See, what are the integrity constraints in a database system having? There are totally 5 integrity constraints the database system is supporting. What are that 5 integrity constraints? We call primary key, unique, not null, check, and foreign key. Right, these are the 5 integrity constraints. Now, what exactly the meaning? The primary key. So the name says it is the group of attributes that are primarily used to identify each tuple uniquely. To identify each tuple uniquely, that set of attributes are used is called primary key. So there are 2 things to be noted for each of these constraints. That is this primary key allows null values? Is this primary key allows duplicates? Duplicate values. So is this primary key allows null values? Primary key will not allow null values. Is this primary key allow duplicates? No. So what exactly the meaning? Let us say an example. I do have a table called student. On that we have some attributes: roll number, name, marks, passport. There are certain attributes. Passport. Here roll number is a primary key, assuming. If roll number is a primary key should not be null and should not be duplicates. Say 1 Ajay, marks 21, and the passport is ABC something I'm writing. Okay. Now here in this instance already 1 Ajay 21 ABC, this record is already inserted. Suppose I'm trying to insert one more student with same roll number 1 Priya 20 XYZ. If I'm trying to insert this record, it is going to check the constraints. Here the constraint is mentioned only on the roll number. It is mentioned as a primary key. Generally primary key is represented with underline. Here, okay, I'm writing primary key. If that roll number is declared as a primary key, as we know that primary key will not allow duplicates and null values, but here we are storing a duplicate. If a duplicate is there, this insertion is going to be rejected. That's what we said. It is going to restrict. It means rejects the tuples that can be stored as an instance of a database. When a tuple is going to be inserted, if the tuple satisfy all the integrity constraints that are mentioned on the database schema. If it is satisfying all constraints, then only it is going to be inserted, otherwise it will not be inserted. Okay, fine. The same thing for null values. Suppose you are trying to store null value in this roll number column, that is going to be rejected by the database system. Now look for the unique. The name says unique. Unique in the sense there will be no duplicates. No duplicates. See, there will be no duplicates. But what about a null? It is allowing a null values. It is allowing null values, but no duplicates. Look, suppose I do have a constraint on the name attribute called unique. So means there will be no duplicate names. Already one Ajay is inserted, that is already there on the database system. Suppose if I am inserting 2 Ajay, means roll number 2 with same name Ajay and marks 15 and PQR is the passport number. So what it will do, it is going to check this tuple with the integrity constraints specified over the database and with an existing tuples. Here 2 in the roll number, already 1 was there but not 2, means there is no duplicate and it is not a null value, it is allowed. And here it is a name, on name we have a condition called unique because this first tuple is already inserted with one name Ajay, but I am trying to insert one more student with name Ajay, and that Ajay is duplicating. Because it is duplicating, it is going to be rejected. Then you may be asking a question, sir, here this constraint is allowed, this constraint is violated. Because this constraint is satisfied, this constraint is violated, then this tuple is rejected for the insertion. It does mean that whenever you are inserting a tuple, a complete row should be inserted or should not be inserted. So when this complete row to be inserted, this complete row is going to be inserted if all the integrity constraints are going to be satisfied. Here, this primary key constraint is satisfied, but unique constraint is violated. It is going to be rejected. And not null. Look at, the name says not null. So means it should not allowing any null values. Null is not allowed, but duplicates allowed. But duplicates allowed. See here in the unique you can have a null. Means if you try to insert a roll number 2, null 10, 1, 2, 3, something like this. This is going to be allowed. Why? Because primary key satisfied. Here it is a unique will allow null value and there are no constraints on that. This tuple is going to be inserted. But when it comes to the not null, suppose if I am adding a condition not null to the marks or else not null to the passport, not null to the passport. If it is a not null to the passport, if I am trying to insert some student, roll number 3, name Sita and marks 12 and passport is not null, but I am trying to insert a null value. Just I have inserted null, N-U-L-L. So will this is going to be inserted? No, this is going to be rejected. Why this is rejected? Because rule number primary key is satisfied, unique Sita satisfied because existing tuples are Ajay and null is there, Sita is not there because no duplicate, it is allowed. And here not null condition is there on the passport, but passport is became null because null is not allowed, it is rejected. Simple. And you see the combination of unique and not null, we can call it as a primary key. And fourth one is check. What is check? Check is for defining your own conditions. We can call user defined conditions. Check is for user defined conditions, means you can write your own conditions. Let us say an example, I wanted to write one condition on the marks that every student should have a minimum of 15 marks. So if it is to have a minimum of 15 marks, then we can write a condition over the marks while creation of a table, check marks greater than or equal to 15. Check marks greater than or equal to 15. So what it is going to do, so if I am trying to insert 4, rule number 4 and Rahul and marks is 13 and 1 to 4 is the passport number. Here rule number 4 possible to be inserted because so far rule number 1 and rule number 2 inserted and 4 it is allowed, and name unique, Rahul is not there earlier, and passport is allowed because there is not a null value, and marks have a condition greater than or equal to 15. But what value is inserted? It is inserted with value 15. Because it is inserted with value 15, this is going to be rejected. And you see the existing data also. Look, 2 null 10. Because 2 null 10 and this is also going to be rejected. So it could be something value more than 50, right? So here this is rejected because it is violating the check constraint. You can write your own conditions. And I think once I have read in a social media that one student in one of the university, I don't want to name that university, the student got 110 marks in the drawing out of 100. How this could be possible? How? Means what went wrong in the system? Because on that university, they have prepared some database system, right? On the database system, there is a column called assuming marks. On the marks, they could not return these conditions properly. See here, assuming the marks is for maximum 100. But if I am trying to store one student with marks 110, still it is satisfying the condition marks greater than or equal to 15, this is going to be allowed. So means what is to be done? It is to add with a condition and so we can write like this, check off marks greater than or equal to 15 and marks less than or equal to 100. So what happened in that university, they couldn't write this check condition properly. That lower bound they might have written but not upper bound. Maybe it is a keying mistake while the DTP operator, whoever is entering the marks, he has entered 110 because this upper bound condition is not written, that is accepted, and the student got 110 marks in the drawing and student was in a shock. So that could be happened. Okay, if you didn't write these check constraints properly. Means according to your requirements, you write the check constraints properly, right? Okay, last, foreign key constraints. What is a foreign key? This is used to refer the tuples of other relation, means to have a parent and child relationship, we can have a foreign key condition. Suppose if for every student there is a mentor, means who is a teacher, means there is a teacher who is a mentor. Like teacher ID, if I wanted to add it. And this teacher ID is going to be refer the information about the teacher that was there in the teacher table. Then I can say this data, whatever I would like to store in the teacher ID column should refer the data that was there in the teacher table. Means because it is referring the data that was there in the other relation, then it is called foreign key attribute. It is called foreign key constraint. It is also called referential integrity constraint. And what is the property for the foreign key constraint? Will it allow null values? Yes. And will it allow duplicates? Yes. Let us an example. For Ajay, teacher ID 101 is a mentor. And for this student null, also student ID 101 is a mentor. Let us say some student is there 5, Shiva Krishna, and it is only 40 marks. Okay, it is 40 marks, and 4, 5, 6 is a passport number, and this is inserted. And for this student, there is no mentor, then we can have a null. Means this is a foreign key attribute, and foreign key can have a duplicates and also null values, but the purpose of foreign key is to show some relation between the two tables, right? So to show relation between the tables, we use a constraint called foreign key constraint. We also call the referential integrity constraint. Foreign key allow duplicates and null values. And these are the integrity constraints. In RRB JEE, questions were asked on integrity constraints also. Right. Next, we will discuss about a keys. Here we are going to discuss about super key, candidate key, and primary key. 3 things. First, I would like to talk about super key. What is a super key? See, simple thing, it is a set of fields, or we can call set of attributes that cannot have identical values in all the fields of a key. It doesn't have any identical values. Just now in the previous example, I have explained rule number I can called key. So I used specifically name called primary key, then I will tell you why it is called primary key. So here on the rule number, whatever the tuples that are inserted, this is inserted, this is inserted, and this is inserted. And is it allowing duplicates? No, it is not allowing duplicates. Then it is allowing unique values. Then it is called super key. Look, it is a set of fields that cannot have identical values in all the fields of a key. It's called super key. Suppose I do have a relation R having some attributes A, B, C, D. Now A have some tuples, attributes A1, A2, A3, A4, right? So do we have any duplicates in the column A? No. Then I can call A is a key. A is key. Generally we can call super key. Okay. First I can call super key. Suppose do we have any duplicates? Do we have any duplicates in the B? B1, B1, B2, B2. But here you observe, can I call B is a super key? No. Why? Because B having a duplicates. But what super key says cannot have identical values. But here we have identical values in these tuples. So B is not super key. B is not super key. Look for C, C1, C2, C1, C2. Can I say C is a super key? No. Why? Because C has a duplicates. Because C has a duplicate. C is not super key. Can I call D? Say, let us say D1, D1, D2, D2. D1, D1, D2, D2. So can I say D is a super key? No. Suppose if I make it D1, D2, D3, D4. Can I call D is a super key? Yes, because no duplicates means all are having unique values, no identical values in all the fields in all the tuples. Because in all the tuples for the value D there are different values. D is called super key. Fine. Now I'm asking you a question. Can I call the combination of BC? Can I call the combination of BC is super key? Just think and tell me. Can I call combination of BC is a super key? So what is the definition? It is a set of fields, maybe one fields or more than one fields, that cannot have identical values in all the fields of a key. Look at in all the fields of a key. So means here BC are the fields. Look in all the tuples, the combination you look at B1 C1, B1 C1, 2. So B1 B1 may be duplicated, but the combination I am looking at here C1 it is C2, but the combination B1 C1, B1 C2, these are not identical values in the combination. B2 C1, B2 C2, these are not identical values. Then I can call BC is a super key. Can I call AB is a super key? Just you only tell me. Can I call AB is a super key? Yeah, have a look. AB is a super key. Means the combination of A and B. Look at A1, B1, A2, B1, A3, B2, A4, B2. Is this combination duplicated? No. Because not duplicated, then I can call it as a super key. Right? Are you getting my point? So means the set of fields that cannot have identical values in all the fields of a key for the total tuples, means for all these tuples, means in all these instances that combination of the set of fields should not have any identical values. Because it doesn't have an identical values, the BC is a key, AB is a key, A is a key, D is a key, B is not a key, C is not a key. Right? Okay. Look at, suppose here C1 D1 is there and C1 D1 is there. Can I call CD is a super key? No. Why? Because if I say C1 D1 and again here C1 D1, assuming if it is D1, then it is no longer being a super key for this. So means what super key requires, it should not have any identical values. Means no duplicates, only unique values should be present. So one more important thing is candidate key. This is very important. Look at what is a candidate key? The two distinct tuples in a legal instance cannot have identical values in all the fields of a key. Means same definition. So what does it mean? First, if it is to be a candidate key, first it should be a super key. Correct? First it should be super key before it is going to be a candidate key, because same condition. And the second condition is the no subset of the set of fields in a key is a unique identifier for a tuple. So look at no subset of the set of fields in a key is a unique identifier. What does it mean, no subset of the fields of a key? Suppose if I am taking AB, assuming if AB is super key, because means first condition is satisfied. If AB is a super key, what second condition? No subset of the set of fields. What are the subset of set of fields? A and B. Instead of saying just subset, we can call proper subset. Why? Because any set is a subset. So I can, just to avoid that confusion, I can use a point no proper subset. So what are the proper subsets? A and B. What are the subsets of AB? Pi, because null is a subset of any set. And itself is also a subset, we can call it. That's why, to avoid that confusion, I'm just using a word proper subset. So what are the proper subsets? A and B. So what is the condition? No proper subset of this set of fields in a key is a unique identifier. Means A alone is not super key, right? Because it said no, not super key. B alone is not super key. But together, it should be a super key. That is the meaning of the second statement. Means the first condition, it should be super key, as you know that unique identification. And the second condition says no proper subset is a unique identifier. Means no proper subset is a super key. So means A and B, if it is super key, A alone should not be super key, B alone should not be super key, then only it is called candidate key, right? Now look at this point. A is a super key, already we have defined. Because it is a single attribute, will it have any proper subsets? What are subsets of A? Pi and A itself. Because pi and set itself will not be considered as a proper subset. Means there will be no proper subsets. It means we can take it as a grant that a super key with one attribute is a candidate key. B is not super key. C is not super key. Because if it is not super key, we should not worry about the second thing. Because if it is not super key, it is not candidate key. Why? Because if it is to be a candidate key, the first thing, it should be a super key, correct? So, okay. So, A is super key as well as candidate key. B is not super key, means not candidate key. C is not super key, not candidate key. D is super key, so it is a candidate key. BC is a super key, but is it a candidate key or not? You look. Suppose if BC is a super key, here, if BC is super key, if it is to be a candidate key, what will be the condition? B is not super key and C is not super key, correct? Now, B is not super key, C is not super key. Look, is B super key? No. Why? Because we have a duplicate. So already have written B is not super key. Is C is a super key? No. We have a duplicate. C is not super key. Because B is not super key, C is not super key, but BC together is a super key, it means that BC is a candidate key. BC is a candidate key. And look for AB. You only tell me, is AB is a candidate key? When AB is a candidate key, if AB is to be a candidate key, first AB should be super key. Okay, first thing, AB is a super key, happy. But what will be the second condition? A is not super key, B is not super key. Look, and this is an AND condition. A is not super key and B is not super key. A is already super key. Because A is already super key, AB is not candidate key. It is only super key we can call. So means we can call it is not candidate key. Right? Now, you observe one point. A is a candidate key as well as super key. Right? A is a candidate key as well as super key. D is a candidate key as well as super key. BC is candidate key as well as super key. AB is super key but not candidate key. Means what are the candidate keys for this relation? A, for this instance, A and D and AB are the candidate keys. A is a candidate key, D is a candidate key, AB is not candidate key, and what is a candidate key? BC, sorry, yeah, BC is a candidate key. So how many candidate keys we have? A, D and BC for this example. Just in this example, A, D, B, C are the candidate keys. It means one relation may have more than one candidate keys. Among the many candidate keys, it is recommended that the database designer can identify one of them as a primary key. Database designer is recommended to identify one of them as a primary key. Look, we have a three candidate keys, A, D, B, C. Among the three, you can choose any one as a primary key. Now question comes, because three were there, which is going to be chosen as a primary key. Can I choose A as a primary key, or D as a primary key, or B as a primary key? You can choose any one, no issue. But the designing convention says that when lesser number of attributes are sufficient, don't take more number of attributes as a primary key. So in that context, I don't take, means we can take, but I don't take. I'm a database designer, I don't take BC as a candidate key because A and D options are available. So means either A or D should be chosen as a primary key. And that primary key you choose based on your purpose. So it is completely your choice if you are designing a database system. Let us say an example in the previous case when I have designed a student table having two unique columns, assuming one is a roll number and one is a passport number. I can choose either roll number should be a primary key or I can choose passport number should be a primary key. Anyone, it is okay. But the point is, for what purpose you have designed the database system is important. Suppose you have designed a database system, a student table to be used by the college. In the college, students are basically identified by their roll numbers, then I can call roll number is a primary key because it simply means that your purpose says which is going to be a primary key. Right. So means in any relation, how many primary keys should be there? Only one primary key. That one primary key should select from available candidate keys. And one more important thing, every candidate key definitely be a super key. But every super key need not be a candidate key. Just let me show this example. See, AB is a super key, but not candidate key. But whichever is a candidate key, it is also primary. Sorry, it is also, whichever is a candidate key, it is also super key. Look at, this is a candidate key, also super key. This is a candidate key, also super key. But it is a super key, but not candidate key. What does it mean? Every candidate key is a super key, but every super key need not be a candidate key. So how many primary keys are allowed? One primary key. That one will be subset of candidate key, and all these candidate keys are subset of super keys. Right? Okay. This is about the integrity constraints that we have discussed. Right. Now we will discuss some of the previous RRB JEE questions which were asked based on the concepts that we have discussed in this session. Before this, look at, it is a practice question. Which of the following is not a super key? Just I can give you some time to understand which of the following is not a super key in a relational schema with attributes V, W, X, Y, Z, where the primary key is Vy. The primary key is Vy means we can call it as a candidate key. So question is about super key. What super key? Super key should have a candidate key. Look, Vy there. First it should be unique because if it is a candidate key means it is a unique identifier. So because it is a unique identifier, we can call it as a super key. Here V there but not Y, it is not super key. Here V there, Y there, it is super key. Here V there, Y there, it is a super key. So the question is about not super key, that is an option B. Look at this question also. Given an instance of the student's relation as shown below. Student ID, student name, student email, student age and CPI. Some table of data is mentioned. Look at the question for student name comma student age. Student name comma student age to be a key. For this instance, the value of X should not be equal to. Here in the table, X is mentioned. The question is that X should not be equal to which value? But what is mentioned, student name and age to be key. Student name and student age to be a key. If it is to be a key, as you know that key should not have any duplicates. Look at Shankar X, this is one tuple. Do you have any other tuple Shankar? Yes, means here duplicates are there, but that combination should not be duplicated. That Shankar's age is 19. Suppose if it is equal to 19, what happens? Shankar 19 is duplicated, then it is no longer be a key. If it is to be a key, this first tuple Shankar age should not be equal to 19 because second Shankar's age is already 19. So means if in order to be a key, the student name and student age, that X should not be equal to 19, right? So what is the answer for this question? 19. Yeah, here this is the previous RRB JE questions. This is RRB JE 2014 question, green shift. And the question is the main function of database is to. What is the function of database? It is to check all the input data. Is it check all spellings? Okay, spellings cannot be verified. Okay, spellings cannot be verified. Collect and organize input data. Yes, database system is to collect the data and organize the data. So we can call the option C is the perfect answer. Data items grouped together. Data items grouped together for storage purposes are called. If data items are grouped together, like rule number 1, name Suma and marks 25. These are the data items are grouped together to form one record, or we call one tuple. So what is the answer for this? Record. Look at which of the following is a DBMS software. Which of the following is a DBMS software? What DBMS software contains? Database manipulation language, which is to manipulate the data, means like insert, delete, update. These are all called manipulations. To manipulate, it requires to have database manipulation language. We call generally DML language, and it is part of DBMS software, and should have a query language like SQL. It is also part of databases, and some utilities like buffer manager, transaction manager, concurrency control manager, that are all called utilities. And all these forming a database management system software. We can call all of these, right? And look at which of the following is not a relational database. What are the RDBMS examples? RDBMS example, Oracle is RDBMS, Microsoft SQL Server is RDBMS, Sybase is RDBMS. These were known. Right, Oracle is developed by Oracle Incorporation. Microsoft SQL Server, it is developed by Microsoft. Sybase is developed by a Spanish-based company. Now these three we know it. Ultimately answer is option B, integrated database management system. Actually, integrated database management system follows a tree-like structure. Tree-like structure means it will use as an hierarchical model, and this will be used in the mainframes, but not uses a table of data in IDBMS. So this is not RDBMS. So because question is about not a database, not an RDBMS, we can call integrated database management system. It is a RRB JE 2015 question. Look at this question. And try to answer. Any answers? Look at. Which language has recently become the de facto standard? Actually, the de facto standard in the sense, the DBM means the product, or we can say the product or anything that got popularity in the market and accepted by many people, then we can call it as a de facto standard. So question is, which language has recently become the de facto standard for interfacing application programs with a relational database system? So to interface an application programs with an RDBMS, which RDBMS is considered as a de facto standard? Means that is accepted in the market, accepted by many people and have more fame. So Oracle is one that recently became the de facto standard for interfacing application programs with RDBMS. This is Oracle is accepted, means has a market value and accepted by many people, and that's why Oracle becomes the de facto standards. So answer is on option A. This is an RRB JEE 2014 question. And here 2014 question, look at which of the following is not a characteristic of a relational database model. In relational database models, we represent database in the form of tables, and tree-like structures will called hierarchical DBMS. This is not a characteristic of RDBMS. This is called hierarchical DBMS. So this is not the characteristic of RDBMS, and RDBMS is used to represent the complex logical relationships between the tables, and it is going to store some records. These are all the correct things. Which is incorrect? B. Look at another question. It is also 2014 question. In relational schema, each tuple is divided into fields called. A tuple is divided into fields, attributes. But here you look, attribute is not there. But each attribute can store set of values. The set of values that each attribute will store is called domain of attribute. That word is there. So answer is an option B. The data which is stored in the database at a particular moment, you only tell me, at a particular moment of time is called what? Instance of the database. Just now we have discussed. The candidate key chosen to identify each row uniquely is called. So which candidate key will be chosen to identify each row uniquely? That candidate key is called primary key. Just now we have discussed. The minimal set of super key, the minimal super key is called candidate key. This is also one of the question that was asked, right? Okay, these are some of the previous RRB JEE questions, okay? And today in this session, we have discussed among the topics some basics of relational model, how data is going to be represented in the relational model, and what are the different terminologies like relation schema, instance, degree, cardinality, integrity constraints, and 5 integrity constraints: primary key, unique, not null, check, and foreign key. And also we have discussed about a key constraints, super key, what is super key, what is candidate key, and what is a primary key. And relation among them and the questions related to it we have discussed. Hope you have enjoyed this session, and definitely you got some good benefit out of this. And just finally, I wanted to end up the session just by the saying of Mr. APJ Abdul Kalam, सपने वो नहीं होते हैं जो सोते समय देखे जाए, सपने वो होते हैं आप जो आपका नींद उड़ाते हैं. What does it mean? You just dream for it to crack the RRB JEE. Definitely one day or other day you are going to achieve it. So means you dream for it, and that dream will not let you sleep, and that dream will always alert you to go for your preparation in the right direction. So I request all of you, please dream for it to crack RRB JEE and going to achieve it. And just I wanted to end up this session with a big thank you. And thank you one and all for your patience and listening to me. And hope you have enjoyed the session. Wishing you good luck. Thank you.